Hi, today we would like to see this coding problem of minimum subarray sorting. What is this problem is about? So we have been given this input list, and this is partially sorted and partially unsorted list. So we need to find the indices from where the unsorting has started and unsorting has ended. The other thing here is this list can contain many number of unsorted parts, unparted portions, but we need to just provide the minimum number of that subarray subarray which got unsorted. So in this, what happened was, so 1247. So if you see, 6 is missing here, and it has 6 has to be present here. 6 7, if it has to be completely sorted. So this is the part, this is the index which uh, that is the minimum subarray that we can find here. This is the answer, 39. So, and finally, if you see here, if you sort this 6 7 7 7 10 11 12 16. So this is the part where this is the index where it has got unsorted. 12 has to be present, but 7 is present. So that is 3 and 9 here. That is the answer. So in case if there is no sorting required, there are no unsorted portions in this given input list, then you just return -1 -1, means there is nothing uh, unsorted portions in that. Okay, so how to solve this problem? So basically the logic that I think of this is, this is a partially sorted list. So if you can find what are those unsorted numbers and find the minimum and the maximum of that unsorted numbers, and if you can find the indices which that numbers has to be present, that is the final answer. Say for example, so to explain my logic, here it is unsorted, and so as I told, 6 and 12 are the small, this is the subarray which got unsorted in this, because this part is sorted, this part is sorted, this part is unsorted. So 6 and 12 has to be present here, which is the smallest and greatest for the unsorted part. So if you can just return the indices of this smallest number and the greatest number of this element, that is the answer. Okay, so as we talked, so we the logic here is we need to do that by initially like finding the unsorted elements, finding the unsorted elements. After finding the unsorted element, we need to make sure we need to find the minimum number minimum number of that unsorted and maximum number among the that unsorted uh, list, unsorted numbers. So afterwards we need to just get the indices. This is the logic. So we, regarding the time and space complexities, we iterate through the list once, just once. For calculating these, we might just iterate it again, but it is of big O of n complexity, because we might iterate 2 times of the big O of n, but not n square. So it will be still big O of n. And regarding the space complexities, so we won't be building anything, we will be doing the in place sorting if necessary. So it would be big O of 1. These are the time and space complexities for this. Okay, so regarding the implementation part, how we can do, we just implement this logic. So I'm going to implement in Python. So definition of subarray sort, minimum subarray subarray sort, which takes the input of this list array. I will call it as array. And what we need to find initially, we need to find the unsorted. We need to declare some variables that we will come back and declare here if needed. Say we need to, if before that we need to iterate that, right? So for I in range, we unit iterate completely. So length of this array, length of the array, it will go from 0 to length of the array minus 1. And you need to check whether that specific element is um, out of order. Maybe you can write some function like mm, out of order. Say for example, if is out of order, that specific element, we need to pass the index of that element and the number, where number will be equal to the array of, number will be equal to array of I number and the array itself. So why we are passing array, we need to find that we need to check with the previous number and next number, so on. So yeah, there is a little bit logic there we need to discuss. Okay, so I will write this small is out of order function here. So definition of is out of order, which takes I the index and the number itself and the whole array. We just passing pass by reference. So okay, so we need to initially check. So there are a little bit edge cases, that is, so say for example we got only input list of 1. So can you say anything about this, whether it is sorted or not? We can't say, because if it is single number, it will be already sorted. But if two numbers are there, will you tell whether it's sorted or not? So yeah, basically what I'm trying to say is, if it is at the starting of the list or ending of the list, that is the edge case actually. uh, if it is middle of the list, then that is another condition. Say for example, if I is equal to 0, I mean if it is index 1, index 0, and the number uh, this is the number is the array of the I, is number is less than the next number. Hmm, I think we can write, if I is equal to 0, just return number greater than, if number is greater than, if this number is greater than array of I plus 1, the next number. Okay, otherwise if it is ending, if it is I is equal to length of array minus 1, then what we need to return, we need to return when it will be out of the order, if say this number is, it should be actually more because it is at the ending, but if it is lesser than the previous number, then it will be out of the out of order. So this is regarding if the zero and starting and ending. But what about if that is not occurring and we just need to return regarding the middle elements? How can we say whether this number is out of order or not? This number, that is a number, should be more than the previous number. So return number is greater than array of, this is ith index, so I minus 1. That is one case. Or if number is less than, is array of I plus 1. Is it correct? So I think little bit mistake. This number, this is the number, is greater than the I minus 1, then this has to be less than. What it means is the previous number is more than the actual number. That is out of order. Or the the next number is less than the previous number. So this is what, so we talked about the first element, last element, and the middle element. So this will provide the true or false here. Okay, so if a specific element became out of order, then what we need to do, we need to actually find the minimum and maximum. That is one of the important here. The second, we try to find the unsorted, and finally we find the minimum and maximum numbers. So for that, what I will do is, so I will create a minimum number, that way minimum unsorted number or something. Minimum number, I will call it minimum number, that is unsorted number that we want, and that will be actually the minimum of two numbers. What are the two numbers? I will initially declare this minimum number as, so as this is a minimum, I will create uh, like float of positive infinity. So what I am trying to do is, so if it is a larger number, larger positive number, so I can take this as a base case for calculating the minimum of this minimum number, already existing minimum number, or whatever the number we got here. So this is the minimum. Similarly, we need to find the maximum number, isn't it? So similarly, max number is equal to, I will create uh, as this is max number, as a base case we need to find the uh, very small number, that is, I will take this as minus infinity, negative infinity. So this will create max number is equal to max of, it has to get the max of, this is a negative, so already existing max number and the number. So here it will get the minimum number and the mm, max number. So this part is completed. So for this for loop, it will calculate the minimum number and max number out of this whole given input list. So okay, if the case is like, if the minimum number, if the minimum number is not changed, if the minimum number is equal to positive infinity, it has not changed, because sometimes if it is already completely sorted array, um, it won't change, because this will be positive infinity, and the number, there will not be any number which will um, even I think this will iterate, but this will not be this condition will not be satisfied, this if it is completely sorted. Then in that case, what we need to do, if minimum number is equal to like positive infinity, then just return, as we talked, minus 1 minus 1. then just return, then just return -1 -1. So what this will do, it will complete this function, and it will just return -1 -1 list. But what if it is not? We found the minimum and maximum numbers, and we are just trying to find the minimum number comparing with the infinity to make sure that this function at least ran for few numbers, and still we can get, it is not completely sorted list. So okay, if this is not passed, what we need to do, we need to find the indexes of those numbers. Now we got the minimum and maximum numbers, so we need to just say, for example, we got 6 and 12 as the minimum and maximum numbers. So we need to find what is the position that we can keep here. So just iterate through the list through a while loop. So we knew that. So while, so minimum number, so minimum number is greater than or equal to array of some, I will call this as left index, and this is called as right index. So I need to declare those variables here. I will call left index. Left is left index. So left index is, initially I will keep that as 0, 0, and right index I will put that as the end of the list, length of the array -1. So minimum number greater than or equal to this array of left. What we did, we checked that we knew that there is a minimum number, say for example 6, and we are starting from zeroth index of the list. Say 6 greater than or equal to 0. Yes. So if that is the case, if 6 is greater than or equal to 0, just then increment the left. So just moving towards to the next part. So increment the left by 1. That's what we are doing. And at some moment that, okay, there will be 6 and greater than is 6 greater than or equal to 7 at this position. So 6 is not equal to greater than or equal to 7. So what that means, mm, now previously, like before coming to this position, it will have the left. Say for example, we can iterate through this small list because it is small list. Okay, so 6 is greater than or equal to 1. Then initially left index is 0. um, this has become true, and we update increment left by 1. So now it moves here. So we will check again. 6 less than or equal to 2. That is true. So this will be incremented left by again 2 by 1. Left becomes 2, and it comes here like 6 becomes 4. This 2 becomes 4. Is 6 greater than or equal to 2? So yes. So this becomes 3. So finally, currently we have the left index as 3. Now we will check that 6 greater than or equal to 7. So this condition will not be satisfied, and we have this 3 in the left index. So that is the one of the answer here. So similarly, we will write for, we need to find for max number. If max number, we knew that this is the unsorted part in the max number, so we need to find the array. So array of right. So this will be initially array of right. Array of right is the last number, length of the array -1. So it will initially check max number. We knew it is 12 and is less than or equal to this number. So 19. This is true. So initially the right is 12, and as this is true, this will be decremented by 1, right? Minus 1. So this will be decremented, and we go to the 11th index. What is 11? Here it is 18. So still it will be true again. It will be, so it will become 10. If 16, it goes to 16, and 16 is still bigger than the 12. So this will become 9. So then it will come to 7. So 7 is not greater than 12. So at this moment we are left with right index as 9 index. So these are the elements we just need to return these, return in a list the left and right. So this will execute in a time complexity of the implementation part is completed. So this will execute in a time complexity of, it is running over the given input list, just calling this another function. This will execute in a big O of 1, like uh, time. So this doesn't affect any time complexity. So, and this is the only part which we are iterating. Just one thing to say, this is correct. So this will be iterated, and this will be all in one line. Yeah. So the time complexity will be big O of n, where n is the length of the input list, and space complexity is, we are not storing anything anywhere, just the variables. So big O of 1. So this is regarding the finding the minimum subarray unsorted problem. This completes this.